Alright, today we're going to discover why thermodynamics blows, as in sucks. An old Full Metal Jacket poster, their reference, the very old Full Metal Jacket poster, movie by Stanley Kubrick. He had on the poster in Vietnam, the wind doesn't blow, it sucks. Anyways, let's take a quick look at why thermodynamics is terrible. In thermodynamics, you'll have problems or situations with equations, and you might need to know a couple of constants, and you could have some integrals and maybe some differential equations. The next level is when you have equations with tables for properties of certain heat capacities, constant pressure and volume, heat of vaporization, heat of freezing, latent heats for water, gold, heat of expansions. You have the expansion, but those are for just properties, and those tables are not too bad. And the next thing you'll have is tables where you have to figure out the temperature and the pressure, usually before or after. With those tables, a lot of times you'll have to interpolate. We'll see some of these things that I'm talking about in just a second. You'll have to interpolate for the values because they don't give them to you perfect because they want to make the problems as realistic as possible. And or you might have to extrapolate the value if the value is not within the tables that are given. And then you haven't lived with all this nightmare if you haven't had to do with not tables but just graphs. We'll see some of those nightmares. Graphs of thermodynamic graphs of compounds and whatever, where you have to look up values along curves, and we'll see that. And even that, sometimes you have to interpolate or extrapolate if it's not on the on the graph chart. So let's take a look quickly at some of those tables. This is kind of the first one. Has properties of like carbon dioxide and hydrogen, nitrogen. These are gases mainly. Heat expansion and things like that might occur on a different table. I won't worry about that. I'm just trying to show you some of this stuff. Here we start with some what are called air tables right here. You can see how fun they are, and we have equations that have multiple things, PR, VR, and so on, PR, VR, so on. Let's look at some more fun tables in thermodynamics. The question always comes to mind that if you're going to look up tables, why don't you just become an accountant? I know money isn't everything, but you could have made a hell of a lot more money looking up tables. And of course, nowadays, I'm sure everything's done on the computer. You just type in the water vapor at low pressures, the H, the PR, the U, the VR, and so on. I'm sure you look at there's the temperatures and so on. But anyways, these are the fun tables people used to now, have to deal with. Here's saturated steam. I know this is kind of boring, and that's my point of this video, is that it is boring. I'm sorry. I would definitely rather be an accountant and be made a lot of money instead of us. Here's saturated ammonia, right there. Saturated ammonia. I'm sure there's other liquids that are just as fun. Here's more. It keeps on mercury table, and so on. Charts in this, and then I promised you the old curves. Have fun trying to find values of things on these curves. Here you'd have to find a curve, find a point, read a value over here, the temperature is over here, and who knows, God knows what this is over here. These are the entropy diagram for carbon dioxide, by the way, not for ammonia, for carbon dioxide, not carbon monoxide. I'm sure they have that one in here too also. So anyways, you haven't lived until you go through these charts. It's a nightmare. Okay. Real quickly, by the way, I'm a physicist, even though I've had to, unfortunately, teach engineering thermodynamics classes for consulting. And if we look at the back of this is a fairly new book, it's fairly new, 2010. It's a nice statistical and thermal physics. I promise you, they have all the thermodynamic laws and stuff like that. But you know what physics books do not have? Notice if we look at the end of the book, here's the approximations. They have a lot of math formulas, integrals and stuff like that. But physics thermodynamics books do not have any ammonia vaporization charts and entropy charts and stuff like that. And here's the index, which is the end of the book. Okay, so I just wanted to show you the difference between what a physicist has to deal with and what thermodynamically and what an engineer has to deal with. This video is actually something to so people don't feel as if they're alone in their angst against thermodynamics. Here's an old professional engineering exam. It's 1961, but it doesn't much matter. This guy's been teaching engineering examinations for 10 years in California. Anyways, I just thought, this would be a nice thing for somebody for people to realize. Thermodynamics used to cause more difficulty than any other subject among engineers. And this guy's, he's an engineer. He's a consulting engineer, instructor, engineer, University of California, Extension Division, McGraw-Hill. This is not some wacko or whatever. So even an engineer is stating that thermodynamics is a fairly terrible subject for people. It's an important subject, of course. It's important, but it's definitely sometimes a deal breaker for some engineers. Unfortunately, they score fairly poorly on the exam on that. And what's funny is when I taught engineering, if you want to learn thermodynamics, get a good physics teacher to teach you thermodynamics, because he'll rewrite all and engineers write equations differently than physicists. Engineers will they make it easy for them because they're not very good at math, as good as math as physicists. Physicists, it's all about what's called generalization, where you make one equation that can solve a million different situations. And so whenever I taught thermodynamics, I'd have to rewrite all the equations in the thing as basically thermodynamics just comes down to one thing. It's energy conservation. It's the old thing. It's not a new subject. Particles are moving around or vibrating or whatever, and you got to conserve energy. Now you're still going to have to go look up the unfortunately the values in those tables with engineering thermodynamics, but a good physics teacher will make engineering even engineering thermodynamics, like I did. I think I know I'm tooting my own horn, but they'll make a engineering thermodynamics class as easy as possible, even though they'll teach you everything different than the book. But the answers will still, as they did for me, that's how I know I did a good job, is the answers at the back of the book always matched, so my equations worked out perfectly, and they were much simpler for my students to follow. Anyways, just wanted to show you that you guys are not alone in hating thermodynamics, and I hope you enjoyed this video, and I look forward to any comments at the bottom. Thank you.